Python has two primitive loop commands, the while loop and the for loop. With the while loop, we can execute a set of statements as long as a condition is true. The while loop requires relevant variables to be ready. For example, we need to define an indexing variable, such as I, and set it to 1. Now, to introduce the while loop, we use the while keyword, along with the condition. In this case, the condition could be as long as I is less than 6, print I. Now, if we run the program, we're actually not going to get a good output. Notice that it's kind of like going infinitely. And the reason for that is because we need to increment. To increment inside the loop, we need to say something like I equals to I plus 1. Now, when we run the program, we get 1, 2, 3, 4, 5. So the increment here helps stop the loop. Otherwise, it will continue forever. Let's see how this increment here works with the overall loop. Well, we start with I equals 1. So here we're saying, is 1 less than 6? It is. Therefore, the condition is true. And we print whatever the value of I is. Well, the value of I currently is 1. And we call this the first iteration. So now we increment I. So 1 plus 1. And now I is 2. Now we go to the second iteration. Is 2 less than 6? 2 is less than 6. So while true, print the value of I. Well, the value of I now is 2 in this current iteration. And now we move on to the next iteration while incrementing I to 3, because 2 plus 1 is now 3. 3 is less than 6, and then we keep doing the same thing for the next iterations. Then it's going to be 4, then it's going to be 5, and eventually it's going to be 6. Once I is 6, we're going to say, is 6 less than 6? Well, that's actually false. Therefore, the loop terminates and ends right there, and the program ends. Now, we can actually insert an else statement here, and we can say something like print I is no longer less than 6. Now when we run the program, we'll get a nice output statement, I is no longer less than 6, which kind of helps tell the user why the loop ended at 5. By the way, for the incrementer here, we can actually rewrite this in a shorter hand way. So we can actually rewrite it like I plus equals 1. Now when we run the program, we're going to get the same output, 1, 2, 3, 4, 5. We can actually stop the loop even if the while condition is true. To do that, we can use the break statement. So here I can introduce an if condition. If I is equals to 3, for example, break. So now when we run the program, the loop ends at 3. That's because when I is 3, it's going to say, is I equals to 3? Well, 3 equals to 3, true, and then it's going to break out of the loop. Once it breaks, the entire program ends. Now the opposite of break is continue. To use the continue keyword, we need to rearrange the body of the loop here a little bit. And also we need to start I at 0. Otherwise, 1 would not be included. So I'm going to move the incrementer to the top of the loop. And then we're going to say if I is equals to 3, continue. Then print I. Now let's run the program and we'll get 1, 2, we skip 3. So we're basically saying when I is 3, then continue on with the program without 3. And then 4, 5, and 6. Eventually, once we hit 6, then we end the loop and we finish the program. Now, the reason that 6 was actually included in the output here is because, remember, we moved the incrementer to the top for logical reasoning because we included continue in this case. Therefore, because the incrementer is first, 6 is bound to get printed before the loop ends at that point. We can loop through data structures using a while loop. We can loop through a list, such as a list of fruits, for example, this list. Again, we can define a variable incrementer I, and we can start at 0 because remember, lists start at 0, and we can use the while to loop through the list. So the condition for the while in this case would be as long as I is less than the length of the list, and remember, we can use the len function to determine the length of the list, which takes in this list as the parameter. Now we can print the elements of the list, so we can say print this list, and we can print each item in the list by referring to their index. And to do so, we can refer to the index using the I. And of course, we need to increment, so we're going to say I is equals to I plus 1. Now when we run the program, we're going to get the list items printed out, apple, banana, and cherry. In this case, the condition started at I equals 0, and then it said, as long as index I, which is 0, is less than the entire length of the list. The length of the list is 3, so I is less than 3 initially. In this case, we print the first item in the list, which is this list 0, which is apple. Next, we increment I to 1, because 0 plus 1 is 1. And then we say, okay, 1 is less than 3, it is. So that means we still have items in the list, and then we print this list index 1, which is banana. And then we increment from 1 to 2, so now I is 2, 2 is still less than 3, the length of the list, that means we still have items in the list, and then we print this list 2. So at index 2 we have cherry, so then we print cherry, and then we increment I from 2 to 3, 2 plus 1 is 3, and then we say, is 3 less than the length of the list, which is again 3? 3 is not less than 3, so therefore the condition becomes false and the loop ends, and the program ends with it. And by the way, we can do the same thing for tuples as well. It's very similar to the lists, except instead of the brackets, we use the parentheses. And the logic in terms of the loop is pretty much identical to that of the list. We can use the length function to determine the length of the tuple, and then index each item of the tuple like this, similar to lists, and we increment the loop, and when we run the program, we'll get the same output. Apple, banana, and cherry in this case. Now let's talk about the for loop. A for loop is used for iterating over a sequence. That's either a list, a tuple, a dictionary, a set, or even a string. All of these are considered iterable objects. For example, we can loop through the letters in a word banana like so. For x in string banana, colon, indent, we can print each letter in the banana string. So in this case, each letter is represented by the x. Now when we run the program, we're going to get each letter printed out one by one, B-A-N-A-N-A, and the loop ends once the last letter is printed out. With the for loop, we can execute a set of statements once for each item in the list, tuples, sets, etc. So for example, in this fruits list here, we can print each fruit in the list. For x in fruits, colon, print x. Now when we run the program, we're going to get each item printed out, apple, banana, and cherry. Notice, unlike the while loop, we actually did not require to introduce a variable iterator, and we did not require it to index, in this case, a list beforehand. Now, just like the while loop, we can use the break statement to stop the loop before it has looped through all the items in the list. So here, after the print, I can say if x equals to, say, banana, break. Now when we run the program, once the loop hits banana, it prints banana, and then when it evaluates is x, which is banana, equals to banana, when that happens, that means the condition is true for the if condition, so we break out of the loop. And now cherry is not printed because we broke exactly at banana. Now, if we don't want to include banana in the output, it's very simple. We can simply just move the print after the if condition. Now, when we run the program, we will not get banana printed out. So only apple is printed out. And when the loop hits banana in the if condition here, then we break out of the loop. To loop through a set of code a specified number of times, we can use the range function. For example, we can say for x in range, and we can specify a range 6 and print x. The range function returns a sequence of numbers starting from 0 by default and increments by 1 by default and ends at a specified number. For example, in this case, we get 0, 1, 2, 3, 4, and 5. Notice that we started at 0 and we ended at 5 because 6 is not included. Now, by default, the range function used 0 as the starting value, but it is possible to specify the starting value by adding a parameter. For example, I can say 2, 6. So now when we run the program, it starts at 2 instead of 0 and ends at 5 because once again, 6 is not included. Now notice in the output, the range function is defaulting the increment by a sequence of 1. So 2 plus 1, 3, 3 plus 1 is 4, 4 plus 1 is 5. It is possible to specify the increment value by adding a third parameter. So here we can add, for example, 2. Now when I run the program, it's gonna jump by 2. So now we get, instead of 2, 3, 4, and 5, we're gonna get 2, and then skip 3, then 4, and then skip 5, and then it's gonna get to 6, but remember 6 is not included, so then the loop ends. Now assuming a range of 0 to 6, where 6 is not included of course, we can actually include an else keyword in the for loop to specify a block of code to be executed when the loop is finished. For example, here I can say else print finally finished. Now when we run the program, again we get 0, 1, 2, 3, 4, 5 printed out, and again 6 is not included, and once the loop ends, we get the statement from the else block printed out, finally finished, and the program ends. So this way, it's kind of like a nice message to the user indicating that the loop has terminated and ended. Now remember, if we have a break statement, the else block will not get executed. For example, if I had here if x equals 3, break, when we run the program, when x is 3, in the range, then the loop terminates there and the program ends. Now we can actually nest loops inside other loops. For example, suppose that we have the following two lists, an adjectives list and a fruits list. We can print each adjective for each fruit. To do that, we can start with an outer loop representing the adjectives list. So we could say for x in adjective, and here we indent and then we create the inner loop. Now because we're using x in the outer loop, we have to use a different variable for the inner loop. So we can say for y in fruits, and now we can say print x and y. So we get red apple, red banana, red cherry, fresh apple, fresh banana, fresh cherry, tasty apple, tasty banana, and tasty cherry. And the program ends. So what's happening here is that the inner loop, which is this one here, is executed one time for each iteration of the outer loop, which is this one. So in other words, the outer loop starts with for x and adjective list, which is the first item here, red. So for red, and then it applies it to all fruits in the inner loop. So red apple, red banana, red cherry, even though it doesn't make sense for the banana, but this is just for the sake of the example here. And then once it finishes iterating through all the fruits in the inner loop, then it goes to the second item in the outer loop of the adjectives list. So we say, okay, now we have fresh. So then once again, it goes through every item in the fruits list, fresh apple, fresh banana, fresh cherry. And then once it goes through all of the fruits list in the inner loop, then it goes to the last item in the outer loop, which is tasty, and then it applies it to all the items in the inner loop, which is apple, banana, and cherry. And once we have finished all the items in the outer loop, then the program ends once the loop has exited. Now, by the way, let's say that I'm not sure I want to print X and Y just yet. Maybe I'm still designing the program. I'm not sure what to have as content inside the loops here. So if I run the program as is, I'm going to get an error. So let's say you want to avoid the error, but you're still not sure what to put as content in the loop because you're still thinking about it. For that, we can use the pass statement. Now, when we run the program, we won't get an error anymore. We can loop through list items by referring to their index number. For that, we can use the range and the length functions to create a suitable iterable. For example, we can print all items by referring to their index number like this. For I in range length of, in this case, the fruits list, print fruits I. So if we run the program, we get apple, banana, and cherry. In this case, the way this evaluates is we say the range of the length of fruits. So we start with the length of fruits. The length of the fruits is, we have 3 items, so the length is 3. So now we have the range of 3. And remember, when it comes to the range, 3 would not be included, it would be excluded. So technically speaking, it would be the sequence of 0, 1, and 2 as iterable. So then here we're saying for I in 0, 1, and 2, so therefore I in the first iteration of the loop will be index 0, apple. So then we print fruits 0, which means apple. Next, we move on to the next range sequence, which is 1, and then we say fruits 1, which is banana, and then we move on to the next number in the sequence, which is 2, and we print fruits 2, which is cherry. And we exit the loop because the length of the fruits list has been exhausted. Now, suppose that we want a new list containing only fruits with the letter A in the name. For that, we can introduce a new list and say for x in fruits, if A in X, so if you detect the letter A in that item in the list, then append the item to the new list. New list, the append X. And finally, we can exit the loop and print new list. So in the output, we can see that only the items in the fruits list containing the letter A were printed out. Apple, banana, and mango. So cherry and kiwi don't have any A in it. Therefore, they were skipped and not included in the new list. Now, is there a way for us to do this in a shorter way? There is, and this way is called list comprehension. With list comprehension, we can do all of this with only one line of code. So here in the new list, we can specify the expression of the list comprehension, so x, for, followed by the item, which in this case could be x, in the iterable, in this case the iterable is fruits, and we can specify an optional condition. So in this case, the condition would be we are looking for A in the fruit items. So if A in X. Now when we run the program, we're going to get apple, banana, and mango. The same result where the items containing A were appended or included in the new list. The return value of the new list is a new list, leaving the old list fruits unchanged. By the way, the x here, which is the expression, can be manipulated because it can also be the outcome. So for example, let me remove this condition here, and we can say x the upper for x in fruits. And what we're trying to achieve here is we are setting the values in the new list to uppercase. So when we run the program, we get all the values in the old list as uppercase in the new list. So this is how you can manipulate the outcome of the expression in the list comprehension. In fact, we can even set it to whatever we like. We can even replace everything with hello. Hello for x in fruits. So now when we run the program, we'll get hello, 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 hello for every item in the original fruits list. The expression can also contain conditions, not like a filter, but as a way to manipulate the outcome. So for example, we can return orange instead of banana. So I can say here, x if x not equals to banana, else orange for x in fruits. When we run the program, we'll get apple, orange, cherry, kiwi, mango. So we replaced banana with orange anywhere in the list that encountered it. So in other words, we can read this condition here of the expression as return the item if it is not banana, and if it is banana, return orange. Now, of course, in the list comprehension, we can also make the condition be more like a filter that only accepts the items that evaluated true. For example, here we can say if x not equals to apple, and if we run the program, we'll get banana, cherry, kiwi, and mango. So in other words, we're saying include all of the items except apple in the new list. And remember, the condition is optional in the list comprehension, so if we don't include it, we are just going to print all of the items in the new list that were found in the fruits list. Now, one last part of the list comprehension syntax is the iterable. In this case, the iterable is the fruits list, but the iterable can actually be any iterable object like a list, tuple, set, etc. So for example, we can actually say x for x in range, because range is also an iterable, and we can specify a range of 10. Now, when we run the program, we're going to get a sequence of numbers printed out from 0 to 9, because remember, 10 is not included in the range in this case. And of course, we can include a condition. So same example, but with a condition if x is less than 5. So here we're saying accept only numbers lower than 5. So we run the program and we get 0 to 4. Now, similar to lists, we can also loop through tuples. In this case, a tuple looks very similar to the list, except remember, instead of the brackets, we use the parentheses. And we can say for x in fruits, print x. Now when we run the program, we're going to get the tuple items printed out: apple, banana, cherry, kiwi, and mango. We can also loop through the tuple items by referring to their index number. For that, we can use the range and the length functions to create a suitable iterable. For example, we can print all the items as such. For I in range of the length of the tuple, in this case the tuple is fruits, print fruits index I. So now when we run the program, we get apple, banana, cherry, kiwi, and mango. So the way this works is we say for I, which starts at 0, in the range of the length of fruits. The length of the fruits is, we have 5 items in the tuple. The length is 5. Therefore, the range of 5, which means we don't include 5, because remember, the tuple starts at 0. So in other words, we're going to loop through indexes 0, 1, 2, 3, and 4. And once it hits the length of 5, then we exit the loop. We can also loop through set items by using a for loop. In this case, the set is using the curly braces, so this is a set of row items. To loop through it, we can say for x in fruits, print x. Run the program, and we'll get the items in the set printed out: banana, kiwi, cherry, mango, and apple. We can loop through a dictionary also using a for loop. When looping through a dictionary, this dictionary here, the return value are the keys of the dictionary, but there are methods to return the values as well, as we'll see. First, let's print all key names in the dictionary one by one. To do that, we can use a for loop for x in this dictionary, colon, and print x. Now when we run the program, we'll get the keys printed out, which in this case is the type and the name. The values are the fruit and the apple. So to print the values one by one, we could say print this dictionary x, run the program, and we'll get the values printed out. Another way to do this is we can leave it as print x, and here we can say this dictionary dot values, And when we run the program, we'll get the same output through an apple. We can also do the same thing with the keys method. So instead of the values here, I'm going to change this to keys, run the program, and we'll get the keys printed out, type and name. Now, if we want to loop through both keys and values, we can use the items method. So for that, we're going to say for x and y in this dictionary dot items, print x and y. Run the program, and we'll get both the keys and the values printed out.